Hello friends, welcome to my YouTube channel Aviator Updates. If you don't know me, I'm Rajesh Negi and I am an aviation enthusiast. In today's session, I'm going to discuss about ground speed mini of Airbus A320 aircraft. So let us start. Ground speed mini. So friends, what all things will we be discussing over here? We will be discussing about the activation conditions for GS Mini, okay, or ground speed mini. Next we'll be discussing about some general features, okay, and principle of GS Mini. And then we'll be discussing about some basic definitions. Definitions herein I mean to say those definitions which you should know clearly in order to understand the concept of ground speed mini. So only those relevant definitions will be discussed over here. Okay. Then it will be followed by the GS mini computation and the IAS target computation. So all these things we will be studying. So let us start with activation conditions for GS Mini. Okay, so friends, I'm going to write it here. Activation conditions for GS Mini. So in order to start with, first we should know when is the concept or when is the function of GS Mini effective. Okay, the concept of ground speed mini is applicable when the aircraft will be in the approach phase of flight. Okay, so this session is all about the approach phase, wherein the speed of the aircraft should be maintained, okay, by the system. And how is it maintained? By taking the benefit of the ground speed mini. So friends, if you want to take the benefit of ground speed mini during approach, make sure that two conditions are met. So friends, in order to take the benefit of ground speed mini, make sure that you are in the approach phase, and in order to prove that you are in the approach phase, it should be activated. Okay, approach phase should be activated. Okay, so how do you activate the approach phase? You know that in the Airbus A320 aircraft there is a display unit called as MCDU, which stands for multi-purpose control and display unit. There are two MCDUs. Okay, on the MCDU there is a page. In that page you have an option to activate the approach phase. Once the approach phase is activated from there, then we say that the FMS flight phase has been activated, and this is one of the requirement for getting the benefit of the ground speed mini. Okay, second case is the speed target should be managed speed. Okay, you know that friends, in this aircraft, from the FMGS or auto flight system point of view, this aircraft speed target can be managed or selected. Okay, so make sure that the speed target is in the managed mode. Okay, so that's why I'm writing here manage speed. Okay, means you should make the system fly in the managed mode for the speed, then only the benefit of GS mini is effective. Okay, so what are the activation conditions for ground speed mini to be active? First case is like the approach phase should be activated, then only the systems comes to know that you're in the approach phase. And second case is the speed target should be managed speed target, or you can say the speed during the approach should be in the managed mode. Okay, it should not be in the selected mode. Okay, so we'll not talk about selected mode much. We'll talk about the managed mode, in which the speed target is calculated by the FMGS system. Okay, that's called as the managed speed mode. So these two are the conditions for the ground speed mini to be effective, or we can say that in order to take the advantage of the ground speed mini, these two conditions are required. Okay, so that's all. Next we'll be discussing about the principle of ground speed mini. Okay, so what is the principle of GS mini? So let us start discussing about the principle of GS Mini. The concept of GS Mini function has been designed to take the benefit of the aircraft inertia during final approach when the winds are variable. Maybe there is some gust or maybe some wind shear or maybe like longitudinal shears which along the longitudinal axis of the plane. So in these situations when the winds are variable during the approach, the benefit of the aircraft inertia is taken, and in order to ensure this, the ground speed mini always maintains the aircraft energy above a minimum level. Okay, and after some time I'll explain you how the aircraft energy will be maintained above a minimum level based on the calculations. Okay, now you should know that friends, the ground speed mini concept ensures that there is efficient management of thrust when the winds are variable during the approach, and in order to achieve the efficient thrust management, the thrust is varied in plus minus 15% of N1 parameter of the engine. So the objective of ground speed mini is achieved by the calculation of indicated airspeed target. Okay, and that is displayed to the flight crew on the PFD, that is your primary flight display. So that is what you should know about the principle of ground speed mini. So what did we discuss in the principle, friends? The concept of ground speed mini function has been designed to take the benefit of aircraft inertia during approach when the winds are variable. So in order to achieve this, the system assures that there is efficient thrust management by varying the thrust in plus minus 15% of N1 parameter of the engine. Now, this objective of the ground speed mini is accomplished by the calculation of indicated airspeed target, about which we'll discuss after some time. The indicated airspeed target is calculated and shown on the PFD scale in magenta color. Okay, so friends, I hope you are clear with the principle of GS Mini. Now let us discuss some general things about GS Mini or general features. The concept of GS Mini is applicable during the approach phase, right? So this concept is applicable only when the approach phase is activated and the speed is set in the managed mode. In this concept, wind is a key factor in the ground speed mini function. So why I'm saying like this, because whatever speed target, that is the indicated speed target, is calculated by the system, that will be based on the headwind gust or tailwind or longitudinal shears along the aircraft axis. Next, what is the purpose of ground speed mini? The purpose of ground speed mini is to maintain the aircraft energy above a minimum level during approach phase when the winds are variable. Next, as I have told you friends, that the ground speed mini functions assures that the aircraft energy is maintained above a minimum level. Why is this like this? This is basically to provide the standard aerodynamic margins versus stall during the approach phase. This is basically to prevent the aircraft from stalling. Okay, that's why the minimum energy level is maintained. Next, the ground speed mini is not indicated on any display unit to the flight crew. It is just computed by the system in the background, and it is assuring that the aircraft energy is maintained above a minimum level when the wind is varying during the approach phase. Okay, next, if you want to take the benefit of the ground speed mini, do not insert the gust reported by the ATC or TAR in the MCDU performance approach page. Okay, you just need to enter only the average winds reported by the tower in the magnetic wind field of the MCDU, for which we'll discuss for some time. Why you don't need to enter the gust in the MCDU performance approach page and you have to enter only the average wind, that is the magnetic wind, on the MCDU performance approach page, is because the gust is automatically taken care of by the ground speed mini functions whenever you will be in the approach phase with this function activated. Now let's take an example to understand this. Suppose the winds reported by the ATC or tower is 15020, gust 35 knot. So in this case, don't enter this gust on the MCDU. You have to enter only this one, 15020, okay, in the MCDU performance approach page. Okay, on which page? MCDU performance PRF approach page, APPR. Okay, so in this page there will be a column by the name magnetic wind. There you have to enter only this much part. You don't need to enter the gust. Okay, but because, as like I have told you, if you want to take the benefit of GS Mini, this gust should not be entered. It's because this gust or the instantaneous wind, whatever is there, okay, it will be taken care of as the speed is in the managed mode. Okay, and that is by calculating certain value of the indicated speed target, which I'm going to tell you after some time. So friends, I hope you are clear which wind should be entered on the MCDU performance approach page in order to take the benefit of this function. Next important thing which you need to know is whatever would be the indicated airspeed target, okay, it will be represented by a magenta color pointer on the speed scale. Why magenta color, friends? As you must be knowing that in this aircraft, if I talk from the FMGS point of view, when speed is in the managed mode, the speed target is represented by a magenta color pointer. Since in this case also you are in the managed mode for the speed target will be represented by a magenta pointer on the speed scale of the PFD. Okay, that indicated airspeed target, whatever is calculated, it includes the GS mini computation, okay, done by the FG part of the FMGS. Okay, so who does the calculation? It is done by the FG, that is the flight guidance part of the FMGS computer. Okay, that computer does the computation of the IAS target and shows it on the PFD scale. Okay, next there is one important point. Whenever there are adverse conditions related to the severe turbulence, then in that case the use of auto thrust is recommended in order to take the advantage of the ground speed mini functions. Next friends, we'll be learning about some important definitions which are relevant to understand the concept of the ground speed mini. Okay, so some definitions we'll be learning now. Okay, so the first definition is you should know what is the meaning of tower wind. Okay, so tower wind, these are the winds which are reported by the ATC or tower, or through the ATIS you can get it, and these are the average winds which you have to enter on the MCDU performance approach page. Okay, a photo of the MCDU performance approach page you can see here in this photo. Okay, so there you can see that magnetic wind is written. So in the magnetic wind field you have to enter the tower wind. Okay, so what is tower wind? Tower wind is the average wind, okay, which you enter it on the performance approach page in the column by the name magnetic wind. Okay, so let me draw MCDU again. So on the MCDU there will be a field by the name magnetic wind. Okay, so in the magnetic wind column you have to enter this wind. Suppose the tower has given the wind to be 1502 knots. So I'll enter on the scratch pad and I'll press the line select key, and here the tower wind will be 15020. So friends, this is the tower wind which you have entered. So I hope you are clear what is tower wind. Next is headwind component. Tower headwind component. What is the meaning of tower headwind component? Suppose this is your runway, okay, and this is the axis. So whatever would be the component of the magnetic wind given by the ATC or tower or through the ATC you are getting, so the component of that wind which is projected along this landing runway, okay, that component is called as the headwind component. Okay, so when you will be coming for approach like this, whatever component of the headwind is along the axis of this runway, that component is called as the tower headwind component. Okay, so I hope this is also clear. Okay, so we have discussed tower wind and tower headwind component. So again I'll tell what is tower headwind component. Tower headwind component is a component of the magnetic wind, okay, which is projected along the axis of the runway. Okay, of which runway? Of the landing runway which you have selected, okay, for landing using the MCDU. Okay, so landing runway you can select it from the MCDU. Suppose you have selected ILS 27. So ILS 27, suppose this is the runway. So along this runway axis, whatever would be the headwind component, okay, that component of the magnetic wind is called as the tower headwind component. So I hope friends you are clear with the tower headwind component. Next, you should know about current headwind component. Okay, so what is current headwind component? As the name says, current means when you will be in the approach phase. As you know friends, I am just considering the approach phase to explain the ground speed mini concept. So suppose you are in the approach phase, so whatever headwind component is measured by the adders. Okay, what is adders? ADIRS. Adders stands for Air Data Inertial Reference System. This is the system which is there in this aircraft. Okay, there are 3 systems installed in this aircraft. This system senses the air data and gives you all the parameters. Okay, this system is a combination of air data and inertial reference system. So this system, it can measure how much is the headwind. Okay, so during approach phase, whatever headwind is measured by the adders around the aircraft longitudinal axis, okay, that wind is called as the current headwind component. Okay, I repeat again. Suppose this is your aircraft. My hand is representing your aircraft, and this is the longitudinal axis of aircraft. So now whatever headwinds will be there, which will be projected along the longitudinal axis of this aircraft, okay, during the approach phase, can be measured, and this is measured by the ADERS system. Okay, so this headwind which is measured by the ADERS system is called as the current headwind component. Okay, what is this? Basically, this is the instantaneous headwind. Okay, so you can say that the current headwind component is the instantaneous headwind component which is projected along the aircraft axis, and it is measured by the ADERS. Okay, ADIRS system, Air Data System, which the full form of ADERS is Air Data Inertial Reference System. So friends, I hope you are clear with the current headwind components. So these three definitions you should be knowing in detail. Okay, tower headwind component, which is reported by the ATC, and you enter on the MCDU performance approach page here. Okay, suppose this is your MCDU. Okay, approach page is this one. Okay, so you have entered it here in the magnetic wind field. Next thing which we discuss is tower headwind component. So this was the component of the headwind which is projected along the landing runway, whichever you have selected in the FMS flight phase for landing. Suppose we have taken the example of ILS 27. Suppose in the FMS flight plan you have selected ILS 27 for landing. So along the ILS 27 runway axis, whatever is the headwind component, okay, magnetic headwind component, that headwind component will be called as the tower headwind component. Next is the current headwind component. Current headwind component is the instantaneous headwind which is sensed by your aircraft ADERS system. Okay, and I hope you are clear with these three definitions now. Okay, next definition which you should know is about the approach speed, the final approach speed, okay, which is called as VAPP. Okay, this final approach speed you should know about it, friends. It has a formula which is programmed in the FMGC also. That formula is VLS plus 1/3 of tower headwind component. Okay, so headwind component is this one. Okay, so 1/3 of the headwind component is this one. So this formula you should be knowing. So how is this formula used? I'll take an example to make you understand this after some time. Okay, once you go through the example, you will become master of the ground speed mini function. Okay, about that we'll discuss after some time. Next, this approach speed can be VLS plus 5 knots also. Okay, so amongst these, like VLS plus 1/3 of headwind component or plus 5 knots, whichever is higher, okay, will be considered for the approach speed. Okay, and this 1/3 of headwind component also has two limits. I'll write them here. One is 0 knots and the other one is 15 knots. Okay, so 1/3 of headwind component will have 0 knots whenever there is no wind, means wind is 0, or whenever there are tailwinds. So tailwinds, this is asking you about the headwind. So if tailwinds are there, obviously no headwinds, that means 0 it will be. So this 1/3 of headwind component will become 0. So in that case, VLS plus 5 knots will be preferred. So as I have told, this final approach speed, which is your VAP, okay, this is basically the higher of these two. So which one you should select, this one or this one? Whichever is higher amongst these two, VLS plus 1/3 of headwind component or VLS plus 5 knots, whichever is higher will be considered for the approach speed. Okay, so now in this I have explained you that 1/3 of headwind component has two limits, 0 knots, about which I have told you already. Now let's talk about 15 knots. This 15 knots can be there when the tower given wind will be around 45 knots, because 1/3 of 45 knots will come down to 15 knots. Okay, so 1/3 of 45 becomes 15 knots. Hence, moral of the story, this parameter 1/3 of headwind component has two limits, 0 knots and 15 knots. 0 knots in the case when there is no wind or when there are tailwinds. So whenever there are tailwinds, obviously there will be no headwind. So in that case, it becomes 0. Okay, so when it becomes 0, VAP will not consider this. It will consider this VLS plus 5 knots. Okay, 5 knots is always a buffer, you should know that. Okay, to calculate the final approach speed. So this formula is basically programmed in the FMGC computer, and it always takes into consideration these factors, whatever we are learning right now. So friends, I hope you are clear what is VAP. VAP is your final approach speed, which is calculated based on these, and whichever is the higher, that will be preferred for calculation of the VAP, that is your approach speed. Okay, I'll just erase this. Now friends, where is this VAP, that is the final approach speed, indicated? Okay, so let me take a short example to make you more clear. Suppose your VLS is 130 knots. Okay, how is the VLS calculated by the system? For this I have already prepared a special video and I have shared the link below. Okay, you can check it out for VLS. As of now, let us consider VLS is 130 knots. Now with this VLS, I'm writing here 130. So instead of VLS, I'm writing here as 130 plus. Suppose the winds are the same one, 150/20. So 20 are your wind information. So 1/3 of headwind component was the formula, right? VLS plus 1/3 of headwind component. 1/3 of headwind component. Headwind component, this is a headwind which is reported by your ATC. Okay, so 1/3 of 20 knots. How much it is? 6 point something. So let us consider it to be 7. 130 plus 7. How much it becomes? 137 knots. So this is your VAP. So if you see the lower formula, here it is VLS plus 5 knots. How much it will be? Let me write it here. It will be 130. So instead of VLS, I am writing 130 plus this 5 knots exactly I am writing here. It becomes 135 knots. Suppose this is your formula number 1, this is your formula number 2. So amongst them, whichever is higher will be preferred. So as per formula number 1, we are getting 137 knots. Okay. And as per formula number 2, we are getting 135 knots. Okay. So which one will be preferred? 137. So 137 will be indicated on the MCDU. Okay. VAPP. So this is a field. Okay. Where you can see the VAP. How much it is right now? 137. 137. So FMGC is programmed with these formulas and it can compute and show it here 137. Even the VLS is also indicated on the same page. Okay. That is 130. Okay. So this is generally indicated in green. This is in blue color. Okay. We have nothing to do with the colors right now. Now during the approach phase, the pilot can modify this approach speed. About that I have talked about in my previous session also, for which I have shared the link below. Okay, so moral of the story, on MCDU you get the magnetic wind data, you get approach speed, you get VLS. So approach speed is a concern right now. So approach speed you see here, magnetic wind you see here, right? Now let's do the GS mini computation. So in order to compute the GS mini, so that's our next topic, GS mini computation. So I'm drawing a line here to compute the GS mini. So friends, in order to compute the GS mini, there is a special formula, okay, which you should note it down now. Okay, so GS mini, okay, the formula for computing this ground speed mini, okay, is VAP minus tower wind. Okay, so if I consider that example, so you can see VAP, where do you see? Here it is 137. So I'll write here 137. Tower wind, how much it is? 20 knots. Okay, so tower wind, I have already told you what is the definition of tower wind. Tower wind is the wind which is given by the ATC, or you get it through the ATIS. So that tower wind, suppose it is 15020 knots. So this 20 knots is written here. So minus 20, that's your tower wind. So the formula of GS mini is VAP, that is the final approach speed, minus tower wind. Okay, so VAP in our example is 137 and tower wind is 20. So on the MCDU, okay, if you subtract this with this, you get the ground speed mini. How much it is right now? 117. Okay, knots. Okay, that's your ground speed mini. So in this example, it is 117. So friends, I hope you are clear with the calculation of a ground speed mini. This is how it is calculated. You have to remember this formula. Now this ground speed mini, 117 knots, this is never indicated to the flight crew on any display. Okay, this is mini. Why it is called mini? Because this is the minimum speed which the aircraft should maintain during the approach phase. In order to maintain this, the thrust will be varied. Sometimes it will increase, sometimes it will decrease based on the winds. Okay, if there are headwinds, then the engine energy has to increase to maintain this. If there are tailwinds, then the engine energy will decrease in order to maintain this. Okay, so ground speed mini, this will become more clear when I'll do the example which I said I'll do in the end. Okay, so as of now, this is just a basic formula to calculate the GS mini. Okay, not the basic one, the actual formula to calculate the GS mini. So friends, I hope you are clear how to calculate the GS mini. It is computed by using this. So just by looking at the MCDU, I repeat again, just by looking at the MCDU, you can calculate, or you can get to know how much is the ground speed mini, how much it is. So this is the MCDU. So you know, suppose you are sitting on the captain's seat and you are looking on the approach page. So on the approach page, just see the approach speed, that is your VAP, and the wind, whatever you have entered on the magnetic wind column. Okay, so from this you just subtract 20 from this. You just subtract the tower wind from the approach speed, and you will get to know how much is the minimum speed which is required by the aircraft during the approach phase. Okay, and this will tell you that how much minimum energy the aircraft should maintain. Okay, so at the time of touchdown, you'll exactly get to know how much is the minimum energy level the aircraft is maintaining, and that time whatever ground speed the aircraft would be having, that will be called as the ground speed mini. Okay, so what did we learn? Ground speed mini, is it indicated to the flight crew? No, it's never indicated to the flight crew. It is just computed by the system. So you should be knowing the idea how it is computed by the system. It is computed by using this formula. Okay, why is it computed? Because based on this, the system will assure that the aircraft energy, that is the aircraft thrust, is varied. Okay, so this will act as like a baseline. Why baseline? So that the aircraft is maintaining this minimum energy level at all point of time during the approach. Okay, so now friends, this ground speed mini, as I have told you, it is not indicated to the flight crew. Then what is indicated? The thing which is indicated to the flight crew obviously is the IAS, that is the indicated airspeed. Okay, so IAS is what indicated to the flight crew. Where is it indicated? Suppose this is your PFD. So on the PFD here we have a speed scale, right? So on the speed scale there will be a magenta color pointer. Since the speed is in the manage mode, so in the manage mode you know that the system calculates the speed target and shows by means of a magenta color pointer. I don't have a magenta color marker, so I am just using red ink to tell you that on the speed scale you will get a magenta color triangle, and that indicates your indicated airspeed target. Okay, indicated airspeed target, that is your actual target which system has calculated and shown here. So can you see the indicated airspeed target? Yes, you can see. Where do you see? On the PFD, that is the primary flight display. Where do you see? On the speed scale. How? By means of a magenta color pointer. Okay, so this indicated airspeed target, okay, it will be variable. Okay, it will sometimes increase, sometimes decrease. Why am I saying like this? It will be variable. It's because the system always want to maintain a minimum energy level of the aircraft. Okay, like 117 knots, this is the minimum speed which aircraft want to maintain. So in order to maintain this, if there are variable winds, suppose there are instantaneous headwind gust or maybe shear, okay, longitudinal shear, then in that case, in order to maintain the minimum speed, suppose 117 knots, the engine thrust will be varied in order to accomplish the target speed. So target speed also will vary based on the headwind gust, okay, or a tailwind gust. Suppose there is a headwind gust, then in that case this indicated airspeed target will increase. Okay, and if there is a tailwind gust, then the indicated airspeed target will decrease. Okay, that means this indicated airspeed target is variable because of the winds being variable during the final approach phase. Okay, so in order to maintain the minimum energy level, the system is computing this and assuring that the baseline is maintained by varying the engine thrust. Okay, so that's why we always see the indicated airspeed target whenever we talk about the ground speed mini. Okay, the ground speed mini is not visible to us. What is visible to us in the indicated airspeed target, and how it is visible? It is moving, okay, based on the winds. So the formula for indicated airspeed target is what you should know. The formula for indicated airspeed target, I'll write here, is equal to, this indicated airspeed target is equal to maximum of VAP, or, so I'm erasing this. So indicated airspeed target is maximum of VAP or ground speed mini plus current headwind component. Okay, so this current headwind component, where do you see? You see it on the ND, that is your navigation display. Where is it indicated? If you see, this is your ND, suppose. So on the ND, here it is indicated ground speed and true airspeed. Below that you get the winds information. Suppose the wind is 15030 knots. Okay, so this 30 is your current headwind, okay, as measured by the adders. And headwind, suppose this arrow is there, so this is your headwind. So on the ND, on the top left corner of the ND, you get the current headwind information. So this arrow indicates headwind, and if this arrow is like this, it indicates a tailwind. Okay, so right now it's not a tailwind, it's a headwind. Suppose this is a headwind, and how much it is? 30 knots. So 30 knots is a headwind which is measured by your ADIRS system, and that is called as a current headwind component. Let me remind you again about the current headwind component. Current headwind component is that component which is sensed by the alert system and it is projected along the longitudinal axis of the aircraft. Okay, so that wind, you see it on the ND and it is indicated like this. Okay, so this 30 knots is what we mentioned here. So ground speed meaning plus current headwind component, this a formula for your indicated airspeed target, or you have to consider VAP. Between these two, whichever is higher will be preferred. You can even change this formula. What is the formula of ground speed meaning? VAP minus tower wind. So I'll write here, instead of ground speed meaning, I'm writing VAP minus tower wind. VAP minus tower wind. Okay. Next is this plus. I'm writing here plus current headwind component. Current headwind component. Okay, so now we have a VAP, okay, plus, so this plus I'm writing here, you can write current headwind component minus tower wind. Okay, tower wind component. So this can be the formula, VAP plus current headwind component minus tower headwind component. Okay, so moral of the story, your indicated target speed can be the highest of this or this. Okay, this formula I have split to this one, so I'll just erase this arrow and I'll write here. So your indicated airspeed can be VAP, or okay, or it can be this VAP plus current headwind component minus tower wind. So this is called as the wind gust. Okay, current headwind component minus tower wind. Okay, this is the wind difference. So formula I'll write here for the indicated airspeed target, IAS, that is the indicated airspeed target. Okay, remember that this indicated airspeed target is which speed, selected or managed? It is the managed speed target. So I'll write here, it's managed speed. Okay, it is a managed speed target. IAS indicate on the PFD. Suppose this is the PFD, primary flight display. On the PFD scale, it is indicated by a magenta pointer. It will be increasing or decreasing as discussed earlier. Okay, so indicate airspeed target formula, I am writing it again here. Okay, as this here would not have sufficient space. So it is the highest of VAP. Okay, or you can say VAP plus the wind difference. Wind difference, or you can say the variable gust. Okay, variable gust. What is the meaning of variable gust? Current headwind component. C means current headwind component minus tower headwind. So this is the meaning of your variable winds. Okay, VAPP I'm writing here. The target speed is maximum of this or this. So I'll box it with red ink. VAP this one or this one. Between these two, whichever is higher will be the indicated airspeed target. Okay, so let us consider an example to understand the concept of ground speed meaning overall. Okay, so for that I'll just erase this part. So friends, let us continue with the example which I was saying and explain in the end. Okay, so we are considering the aircraft to be in the approach phase, and the FMS approach phase has been activated. Okay, and the speed is in the managed mode. Okay, you have pushed the speed knob on the FCU, that is your flight control unit. I repeat again, on the FCU there is a speed knob, you have to push it. That means your system is going into the managed mode for speed, that is called as a managed speed mode. Okay, so what we are considering in this example, you have activated the approach phase using the MCDU, and also you have pushed the speed knob on the FCU so that the system goes into the managed speed mode. Okay, so these two conditions we are considering. Okay, suppose this is your aircraft and this is in the approach phase, and suppose this is the runway. Okay, and this is the wind shock to tell you that suppose there are headwinds. Suppose the headwind is like same, let's take 20 knots headwind. Okay, so there is a 20 knot headwind in this runway. So this 20 knots will be reported by ATC or the tower or through the ATIS to your aircraft. Okay, so your aircraft is knowing, and in your aircraft MCDU you have entered the 20 knots. Okay, suppose this is your MCDU, this is your ND, and suppose this is your PFD. Okay, PFD, ND, and MCDU. Okay, on the MCDU, which page is open? Suppose on MCDU, this the page which is open is approach page. Okay, approach. So this is opened by pressing the performance key. On the MCDU, there is a key by the name performance. Through that, you can access this approach page. This approach page, I'll show you how does it look like. There you can see. Okay, this is the approach page. So on that approach page, you can see so many columns are there, like different fields are there, like QNH, temperature, all those things also will be known to you through the ATIS, okay, or through the ATC. So you can enter it on the approach page. Okay, so on the approach page, before we discuss about this example, let me quickly tell you what all things we'll be considering. We'll be considering the VLS, VAP, and the magnetic wind on the approach page. On the ND, you need to know about the ground speed. Where is it indicated? Ground speed is indicated on the top left corner of your ND. Here, ground speed, and below that we have the wind information. Suppose the wind is 15020 knots. Okay, so this is your ND. On PFD, there will be a speed scale, and in the speed scale you will get the speed target in magenta color. So speed target is computed by the FMGC and shown here. On the MCDU approach page, your VAP is indicated here and VLS is indicated here. Okay, so your aircraft is in the approach phase, and while it's in the approach phase, let us consider three cases. Okay, first case, when there is headwind of 20 knots. Okay, next case, suppose there is another headwind of 40 knots. Okay, and third case, suppose there are tailwinds of 10 knots. Okay, so three cases we are considering. Suppose this is a case number 1, this is case number 2, and this is case number 3. Okay, so initially your aircraft will be experiencing 20 knots headwind, and all of a sudden it will change to 40 knots. Then all of a sudden, suppose it changes to 10 knots. So suddenly all these winds are changing. That means winds are variable. Now when the winds are variable, there comes the concept of ground speed, meaning how it is being applied. Okay, so ground speed meaning advantage is it should make the use of aircraft inertia. The minimum energy of the aircraft should be maintained when the winds are variable. So these are variable winds, sometimes 20 knots, all of a sudden 40 knots and headwind, and then all of a sudden 10 knots tailwind. So this is the circumstance, okay, in the example which I am considering. So now in order to understand these three cases, we need some data, like what will be the VLS. Suppose your VLS is 130 knots. So I'm writing here VLS, how much? 130 knots. Okay, which is here. Okay, so VLS is indicated on the MCDU, 130 knots. Okay, so based on your headwind, 15020 is your knots. So you have this and this. So now as per this, you have to calculate your approach speed. So what is the formula for approach speed? Approach speed is equal to VLS plus 1/3 of headwind component. How much is your VLS? 130. So 130 you have already taken here. Okay, so what is your tower headwind? So I'm writing your tower headwind is 20 knots. Okay, this is reported by the ATC or through the ATIS you are getting. So this is your 20 knots. It is your aircraft is knowing about that. So I'm writing here, this is your headwind 20 knots. Now VAP, how much it will be? VAP, it will be equal to, so this is the formula, VLS plus 1/3 of headwind component. So VLS is 130. Okay, and 1/3 of this headwind component, how much it will be? Plus 1/3 of 20 knots. How much it will be? 130 plus 6.67. Okay, so this approximately comes to be 7 knots. So VAP is here 137 knots. Okay, so if you see the other formula, VLS plus 5, it is lower than this. Okay, so VAP is the higher of these two, already explained earlier. So we have VAP is equal to 137 knots. So what you will see on the MCDU page here, 137 knots here. So this 137 knots will be indicated on PFD by a magenta color pointer. So this one. Okay, suppose 137 is not marked there. So this is 130, 140. Okay, so here is 137. So 137 is indicated right now. Okay, so this is your indicated airspeed target, which is your managed speed target. Why? Because you have activated the managed speed mode by pushing the knob. So 137 is right now is your managed speed target when your winds are 20 knots. Okay, Now, what is the ground speed mini concept here? Okay, so let us calculate how much is the ground speed mini. GS mini. What is the formula for GS mini computation? This minus this means from the MCQ page itself you can make out how much is the ground speed mini. How? Just subtract this with this, because the formula for GS mini is approach speed minus tower headwind. So see, ground speed is approach speed minus tower wind. So this is the approach speed and tower wind. How much is the approach speed, which I have underlined here in green? Approach speed here is 137. So 137. So there is a minus sign here. I am writing minus. Tower wind is 20 knots as reported to our aircraft, okay, through ATC or ATIS. So I'll write here 20 knots. So it comes how much? 137 minus 20 is 117. Now this 117 knots, okay, this is a ground speed mini. Mini means minimum this much speed should be maintained by the aircraft, okay. And how it will maintain, for that we are discussing these three cases, okay. So this is the minimum speed which aircraft should maintain, and that's why we say the ground speed mini concept or the ground speed mini function, okay, assures that a minimum energy is maintained during the approach phase in order to assure that the system provides aerodynamic margins versus stall. Means the aircraft should not stall whenever aircraft is in the approach phase and there are winds, okay, because sometimes there will be low energy. Some minimum energy should be maintained to prevent the stalling from happening. That's why we say that minimum energy should always be maintained by the aircraft. And how much is the minimum energy? It is as per this speed. It is 117 knots as per this example. Okay, so this much is what this aircraft should maintain minimum in the managed approach phase. Now if I take case 1, so in case of case 1, okay, what you can see is the tower wind, okay, and the current headwind, they are same, okay. So your tower wind and current wind are same. So I'll write here, first case is tower wind is equal to current headwind, okay. Where do you see the tower wind? Tower wind is on the MCDU and headwind is on the ND. That's why I have drawn MCDU and ND side by side here to make you clear, so that on the MCDU you can check what is the tower wind, okay, and what is the current headwind. So if you see both are same, 20 knots here and 20 knots here, this is your case 1, okay. So in case 1 you have tower wind and headwind same. Tower wind is 20 knots and current headwind is also 20 knots. So both are same. So what will happen when both are same? In this case, minimum speed which aircraft will maintain is 117 knots. So if you see on the top right corner of ND, the ground speed also will be almost similar to this ground speed mini, which will be 117 knots, okay. So this is your case number 1. This one, when the tower wind is equal to the instantaneous wind or the instantaneous gust headwind, both of them are same. So in that case, how much will be a ground speed mini? Ground speed mini will be 117 knots and your ground speed also will be 117 knots approx, okay. It will be maintaining. So ground speed is clear. Next will be your IAS, okay. Your indicated airspeed, how much it will be? So indicated airspeed will be as per this formula, VAP, okay. So VAP, how much is the VAP? 137 knots, or the next case is VAP plus wind difference, VAP. So how much is the VAP right now? 137 plus difference of these two winds. So here in our example, first case is 20 and 20. So current headwind and the tower wind both are same. So here is 20 knots, here also 20 knots. 20 minus 20 becomes 0. So 137 plus 0 becomes 137. So your PFD will still show you VAP, okay, or you can say indicated airspeed as this much. That means during the approach phase, your approach speed target and the indicated airspeed target are same, okay. So IAS is equal to your approach speed target, okay. Moral of the story, whenever the tower headwind and the instantaneous headwind as measured by the adders, when both of them are same, in that case your indicated airspeed is equal to your approach speed, okay. So IAS is equal to your VAP, okay. So I'll highlight this, IAS is equal to VAP, in which case 1. So what is the moral of case 1? Moral of case 1 is, whenever the tower wind, okay, which is magnetic, okay, which is entered on the MCQ page, whenever the tower wind is equal to your instantaneous headwind which you experience during approach, so in that case your indicated airspeed target will be equal to your approach speed target, okay, which is 137 knots in our example, okay. How about the next thing, which is ground speed? So the ground speed of the aircraft will be equal to the ground speed mini, okay, 117 knots. So both will be same. So ground speed mini will be equal to the ground speed. So this is the other point which you should know about case number 1, okay. Next, case number 2, 40 knots. If suppose you are approaching, all of a sudden the wind changes from 20 knots to 40 knots. So what will happen? Okay. So in that case, let me erase this part. Okay, case number 2. If the headwinds have increased, okay, suppose this is your aircraft and headwinds are more. So whenever headwind increases, what will happen to your plane? It will be pushed rearward. So do you want that? No. So in order to cope up with this, what FMGS system will do is, it will push the aircraft ahead, okay, means your indicated airspeed target will increase, means your speed target will be calculated by FMGC to a higher value, so that aircraft is pushing. So whenever headwind increases, aircraft has to be pushed forward so that the minimum energy level is maintained. How much is the minimum energy level aircraft should maintain? 117 knots at least, okay. So your aircraft speed should not below 117 knots, okay. So what aircraft will do is, the FMGS system of the aircraft will calculate a target speed based on the headwind, okay, which is 40 knots in our example. Based on this headwind, it will calculate a target speed which will be maintained by the aircraft, okay. So I will draw a gauge here, okay. Suppose this is your N1 gauge. Suppose this is your current N1 value, okay, something is there. So in case of case 1, this does not increase or decrease, it remains same, okay, because the tower wind is equal to your instantaneous headwind gust, okay. But right now, this case number 2, 40 knots headwind. So in this case, ground speed mini will be 170 knots, same, okay, it will remain same. But instead of this 20 knots, what you are having, I'll erase this 20, okay, because right now it's not 20, it is how much? 40. So on the ND, 40 knots headwind is there. So based on the headwind, okay, this indicated airspeed target also will vary. How much it will vary? It will increase or decrease? It will increase. Why it will increase? Because whenever there are headwinds, the aircraft will be pushed rearwards. We don't want that. So the target should be increased. That's why whenever there are headwinds, okay, like 40 knots, the target has to increase. So this will increase. But how much it will increase will be based on this. Okay. So now let's do the calculation for your indicated airspeed target. So IAS target will be, let us see, VAP, how much it is? 137 plus, okay, VAP. So higher of this two we have to prefer plus. So VAP is already 137. Let us check with the other formula as well. We always prefer the higher of these two. So it is plus the wind difference. So wind difference is how much? So here wind is current headwind component. Right now it is 40. So I'll write here as 40. Tower headwind component. How much it is? Tower is 20. Okay, tower headwind component as reported by ATC is suppose 20, this one, okay. So tower headwind component, where do you check? Tower headwind component is on the approach page, okay, and current headwind has increased to 40 knots suddenly. So 40 minus 20, how much it becomes? 20, okay. So IS is equal to VAP, which is your 137, and the wind difference is 20 knots. T is equal to 157 knots. So indicated airspeed target will increase. Okay, what does it mean? IAS target has gone to 157 knots. In first case, it is how much? 137 knots. So the target was at 137. Whenever the instantaneous headwind gust was 20 knots, it was 137. But now suddenly when the headwind gust has increased from 20 knots to 40 knots, then in that case this also will increase. Okay, so indicated target speed will increase to 157. So here is suppose 157. Okay, so it has moved from here to here. Okay, why it has increased? I have already told you the reason. Whenever there is a headwind gust, okay, it would like to push the aircraft rearward, but that's what we don't want. Okay, you know, we have to maintain our minimum energy level. Okay, so FMGS system is maintaining it. Okay, how much minimum? 117 knots minimum should be maintained. That much system should maintain. But how much should be the indicated airspeed target? It should vary according to the headwind. Headwind right now has increased to 40, so target speed has increased to 157 knots. So before the target speed was 137, now the target speed is 157. It has increased. That means IAS will increase whenever the headwind gust increases. Okay, so what is the model in case 2? So if I compare case 1 and case 2, in case 1 headwind gust was 20 knots, and in case 2 the headwind gust is 40 knots. So whenever the headwind gust increases, the indicated airspeed target also increases. So you can understand how is the minimum energy level being maintained. How does it increase the IS? Okay, by varying the thrust. So in this case, in order to accomplish this 157 knots, you will see that the thrust also will increase from here. Okay, you will see that the value will increase. So this will not be your current thrust now. The current thrust will be this one, which will increase. So what are the points which you should note whenever gust increases, headwind gust increases? Whenever headwind gust increases, first point, indicated airspeed target will increase. Okay, so it has increased. In our example, it has increased from 137 knots, which was in case 1, to 157 knots. It has increased. Second thing, in order to accomplish this, okay, and also in order to maintain the minimum energy level, the engine thrust will increase. How much will increase? You will see it on the gauge. So you will see an increment in the thrust. Next, how about the ground speed? Ground speed, okay, in this case, ground speed mean is 117. So this minimum energy level is still maintained by the aircraft. So on the ND, you will still see 117 approximately is being maintained by the aircraft. Okay, so ground speed mini, okay, you cannot see this on any display, but you can see the ground speed. Okay, mini is not indicated, but the ground speed is indicated. So on ND, you can see 117 is the ground speed. Okay, so ground speed and ground speed mini will be the same whenever the headwind gust increases. Okay, so right now you have seen headwind gust increase from 20 knots to 40 knots. If suppose the headwind gust decreases again, what will happen? If headwind gust decreases, the target speed also will decrease and the thrust also will decrease. Okay, so since headwind gust has decreased, okay, it is not pushing your aircraft rearward. So in order to maintain the minimum energy level, the target speed also will come down, but it will not come down below 117. 117 will be maintained. Okay, and also it will never come down below approach speed, because the indicated airspeed target should be the maximum of these two. Okay, so whenever it is reducing, you should know that indicated airspeed target has certain limits. Okay, so which I'll write here, IAS target limits. The limits are, obviously whenever I say limit means one minimum and one maximum. Okay, so minimum I'm writing this side and maximum I'm writing here. Okay, two columns. Minimum, it should be approach speed. Okay, suppose your headwind gust has increased in case 2. So when it increased, you know that the indicated airspeed also increased. Now if suppose again the headwind gust decreases, and it decreases, suppose it comes to 0. When it comes to 0, what will happen? So in that case, approach speed is what will be maintained. So the IS target will be equivalent to your approach speed. That means IS will be equal to VAP. Okay, in which case, whenever there is no headwind, okay, no headwind, or if suppose there are tail, so this will happen whenever your current headwind, it becomes 0. Okay, or you can say whenever the current headwind is lesser than the tower wind, or you can say whenever there are tailwinds. So the IS target will be equal to VAP in the case when there are no winds or tailwind. Okay, next case is max. It will be maximum how much? It will be equal to VFE minus 5 knots. Okay, so the IS target speed has a limit of VFE minus 5 knots. Okay, this will happen whenever there are tailwinds. Suppose this is your aircraft. Okay, it is moving during the approach. So when it is moving them during approach, if there are tailwinds, now what do the tailwinds do? Tailwinds, they used to increase the speed of aircraft, right? So do you want a push from the tailwind? No, we don't want, because the system has already calculated and we want to have a stabilized approach. So in order to prevent this, what system does? It will reduce the indicated airspeed target. Okay, and how does it reduce? By reducing the thrust of engine. Okay, so whenever there are tailwinds, okay, the idea is to reduce the speed of the aircraft, and for this the indicated airspeed target will reduce and also your thrust should decrease. Okay, and in addition to this, if I talk about the ground speed, what happened to ground speed? The ground speed will increase. Why? Because tailwinds are there. So when tailwind is pushing, so the ground speed will increase, and in this case we'll get to know that your ground speed mini, okay, which suppose is 170, if you compare it with the ground speed of the aircraft in case of tailwind, okay, the ground speed value will be much more, okay, depending on the winds. So for that we have case number 3. Suppose you are in case 2, 40 knots headwind was there, all of a sudden the wind has changed to 10 knots. So case number 3. So in case number 3, instantaneous tailwinds are there. So tailwinds, how do you identify? So on the ND, instead of this 40, I'll write here as 10. And there are tailwinds. So this arrow direction will move like this. So in our example, we are considering 10 knots as the instantaneous tailwind gust, and that you can check on the ND. Okay, let us discuss case number 3. In case number 3, you have 10 knots tailwind. Whenever tailwind is there, as like I have told you, because of tailwind, the aircraft has a tendency to get its speed increased. We don't want that. Okay, though the ground speed will increase. Minimum ground speed in our case is how much? 117 knots. During approach phase, our aircraft is maintaining 117, but tailwind will add into this. So the ground speed, how much it will become? 127. Okay. So in case 1 and case 2, the ground speed was 117, but in case 3 it has increased because it's a tailwind. So ground speed in case of case number 3, it will be 117 plus 10. How much it becomes? 127. Okay, so 127 I have written it here. So this 127 is your ground speed. Next, how much is the IS? IS will be equal to VAP or wind difference. So here this formula is for your headwind, tower wind. So in this case, we don't have any headwind, so there is a tailwind, so this will become 0. Okay, so once it becomes 0, what is left is VAP. So IS is equal to VAP, and that is how much? 137 as per our example. So IS will come down from 157 knots to 137 knots. So from 157 it will come to 137. So 137 is your target speed now. Okay, so that means whenever the tailwind increases, the IS also decreases, and this is accomplished by the decreasing of the engine thrust. So engine thrust will decrease in case number 3. Okay, so what did we learn? In whenever the tailwinds are there, in case of tailwinds, they add on speed to your ground speed. The ground speed will increase, the indicated airspeed target will decrease. Why it is decreasing? Okay, is because the tailwinds are there. We don't want to be pushed forward. Okay, that's why the system is computing this IS based on the wind tailwind, and it is coming down to 137, which is the minimum target. Okay, so minimum it should be VAP. So VAP is 137 knots. Okay, so in case of tailwinds, whenever tailwinds are there, the indicated airspeed is limited to your approach speed. It should not be below approach speed. Okay, because we have already seen the formula. ISP target is the maximum of this or this. So in this case, VAP is maintained by the aircraft. It will not allow the aircraft to come below VAP. Okay, because that's how the system design is. Okay, whenever tailwinds are there, the IS should not come below approach speed. So that is 137 knots. So on the PFD, we'll see approach speed coming down from 157 to 137 now. That means it has decreased. 157 was in case of headwind gust. Now it's a tailwind gust, so it has come down. So when it has come down, okay, how it is coming down? By reducing the engine thrust. So you will see there is a decrease in the thrust. Okay, so overall you must have seen that the concept of ground speed mini says that there will be an automatic adjustment of the thrust in order to maintain a minimum energy level of the aircraft whenever the winds are variable during the approach phase. Let there be a headwind gust, or there be a tailwind gust, or longitudinal shear. It does not matter. The ground speed mini or concept will always assure the minimum speed is maintained by the system by varying the thrust and by calculating the speed targets, indicated airspeed target, which you can always confirm from the PFD. Okay, so what all things can you see? You can see the variable winds on ND. Okay, whether there is a headwind, tailwind, you can see it on the ND. And based on the headwind or tailwind, how much is the indicated airspeed target changing, that you can check on the PFD. Okay, and if at any point of time, if you can check MCDU, and on the MCDU approach page, you can just subtract the wind from the approach speed. So approach speed minus wind. So approach speed minus tower wind gives you the ground speed mini. So friends, I hope you are clear with the ground speed mini concept. I'll quickly summarize all the 3 cases, okay, based on which you will understand the entire thing. Okay, so what have we discussed this? We have discussed 3 cases. In first case, we are having 20 knots as the headwind gust. In second case, we are having the 40 knots headwind gust. And third case, we are having the 10 knots tailwind gust. Okay, so these winds are variable. Quickly they are changing. Suddenly they are changing from one speed to the other speeds. That's what we are assuming in example, and we are in the approach phase of flight. So during the approach phase, what we have done is we have activated the approach phase, okay, using MCDU, and also we have activated the manage speed mode by pushing the speed knob. Okay, so now how system will behave? System will automatically take into consideration the ground speed mini benefits. How the system, FMGS system, will keep on calculating the indicated airspeed target in order to assure that the minimum energy of the aircraft is maintained whenever the winds are variable this way. So when there were 20 knots headwind gust, okay, and suppose the ATC has reported 20 knots as the headwind, okay, tower wind and the current headwind, which is sensed by the adders of our aircraft while approaching, both of the winds are equal. So when winds are equal, okay, what will be the IAS? The IAS indicated airspeed target will be approach speed plus 0. See how come it is 0? The wind difference, the current headwind component minus the tower wind, okay, it will be 20 minus 20. So this 20 is your current headwind component and this is your tower wind. 20 minus 20 comes to be 0. So that's how your approach speed will be 137 knots. Okay, so your IS is equivalent to your approach speed in the case when this is equal to this. Okay, so this is about your IAS. Indicated airspeed will be 137 knots on the PFD. Okay, how about your ground speed? The ground speed will be equal to your ground speed mini, so that the minimum energy is maintained. Okay, and if you see the thrust, there is not much change in thrust during the approach phase. Next, case number 2, if suppose the winds are increasing immediately, whenever the headwind gust increases immediately, what will happen is, based on the headwind gust, the indicated airspeed will change. How it will change? Since the winds has increased, you can check this on the ND. On the ND, it will show you 40 knots as the headwind, okay, and the ground speed mini in this is 170. So this is your headwind. So whenever there are headwinds, what will happen to your indicated target speed? Whenever there are headwinds, it is pushing aircraft, so the target speed should be increased. So in order to increase the target speed, the engine thrust will increase slightly. So this thrust will increase. Okay, so what have you observed? Whenever the headwind increases, thrust will increase. Okay, thrust increase. Next, IS target has also increased. Okay, why it has increased? Because then only the minimum energy will be maintained. So indicated airspeed target will be increased. How much it will increase? So again, we'll use the same formula, VAP plus wind difference. So there is your VAP 137 knots in case 2 plus wind difference is 20 knots. How come 20 knots? So your current headwind component is 40 knots and tower wind is 20 knots. Okay, 40 minus 20. Okay, so you can see on the ND is here, this is your current headwind, and on the approach speed you can see your tower wind. So you can subtract how much it will be. 40 minus 20 comes to be 20 knots. It is 157 knots. That means whenever the headwind gust increases, okay, suppose there is a headwind coming, okay, in that case your target also will increase, so that your aircraft can cope up with this instant increase in the headwind, okay, by maintaining a minimum energy level. So here you can see that the minimum energy level of 170 knots is there within the plane. It is maintained, minimum energy level is maintained, and in addition to this, to cope with the instantaneous gust which has increased to 40 knots, indicated airspeed target also has increased to 157 knots. Okay, likewise, if headwind gust keeps on increasing, what will happen? In that case, you should know that the indicated airspeed has a target limit. Okay, the maximum target limit is VFE minus 5 knots. Okay, so moral of the story, whenever there is headwind gust increasing and increasing continuously, in that case your indicated airspeed target, okay, also has a limit, okay, which is programmed in the computer, and that limit is VFE minus 5 knots. Okay, that means in case of very strong gust, okay, the indicated airspeed will be limited to VFE minus 5 knots. Okay, next, case number 3, if there are tailwinds. So in case of tailwinds, suppose there is an instantaneous tailwind of 10 knots. So in that case, on the ND you will get to see instantaneous tailwind of 10 knots. Okay, so this is your tailwind. So when there are tailwinds, what will happen? So if tailwinds, they push your plane, in that case aircraft will be pushed forward. Okay, that means your ground speed will increase. So if you see the ground speed mini, which was how much? 117. How about your ground speed? In third case, our ground speed will not be 117, it will increase to 127, because 117 is your ground speed mini plus tailwind, which is an addition to your ground speed. Okay, it makes the ground speed to 127 knots. Okay, so in case of tailwinds, what happens? The ground speed and ground speed mini, if you compare, they will not be the same. Okay, they will not almost be the same, they will be different. Okay, the ground speed increases. Okay, and if you compare ground speed and ground speed mini will be smaller than your ground speed. Okay, so overall moral of the story, your aircraft ground speed should never be lesser than your ground speed mini. Okay, note it down, your aircraft ground speed should never be less than your ground speed mini. it can be equal to or greater than ground speed meaning, but it will never be less than your ground speed meaning, and it should never be less than your ground speed meaning. And for this, the FMGC is always working on it continuously. Okay, this is about your ground speed. Next, what about the IS? So IS will be decreasing because there are tailwinds. So in case of tailwinds, the IS should decrease, and for decreasing this, the thrust should decrease. So thrust will decrease. If you see the thrust gauge on your engine display, you will see that the thrust is decreasing slightly. Okay, so whenever there are tailwinds, what have we discussed? In case of tailwinds, the ground speed will increase, thrust will decrease. Okay, why it will decrease? So that the indicate airspeed target, whatever is reduced, okay, that thing is being achieved. That means the aircraft is making use of its inertia. Okay, thrust has decreased, the aircraft is making use of its inertia whenever the wind is varying as such. Okay, so IS will decrease, but it will not decrease beyond a certain value. And what is that certain value? VAP. VAP is the limitation. Moral of the story: IS target speed limit is limited to minimum VAP and maximum VFE minus 5 knots. So VAP is the case when there are tailwinds, okay, or no winds, and maximum VFE minus 5 knots is in case of headwind gust, if it's very severe or extreme headwind gust. Okay, so these two are the limits of your IS speed target. Okay, so I hope friends you are clear with the concept of the ground speed meaning. Keep learning about this, and if there is any doubt, do feel free to comment below, and I'll be coming up with a new topic in my next session. Till then, enjoy learning and thank you.